Alrighty, welcome back, boys and girls. It's your main mathematician coming to you live from Summit Academy. In this video, wrapping up that Unit 7 by being able to summarize what we have learned from Unit 7 and apply it to different scenarios and different problems. So on the first one, it says select all the expressions that are equal to 3 times 10 to the 5th power. And it says there is more than one answer. So what we can do is let's first kind of see what this looks like. So we can have the scientific notation, or we can say, if we want to switch it to our standard form, again, we circle the exponent and we say, okay, since that's positive 5, we're moving it to the right, and it's going to be 5 times. So what I have here is this. So I have my decimal. I'm going to say I move it 1, 2, 3, 4, 5 times. So I'd have zeros in between. So I'd say this is the same as 300,000. But what we can do is we can kind of switch some of these around, or you can also try using Desmos to be able to solve for these. But what we can do is this. For that first one, you can multiply the first values together. So 2 times 1.5 is going to be 3. And then since we have the same base on these two values with an exponent, we can add, let's say, add exponents together. So I do times 10 to the exponent of 8 minus 3, because it's like we're doing 8 plus a negative 3, which is going to be 5. So that one is going to be good. For our next one, if we look at 30 times 10 to the 4th power, what we can do is we can kind of switch around. So let me make some more space for myself here. Let me write that original one. We said this is equal to 300,000. Okay. So what we can do for this one, let's say if we have 30 times 10 to the 4th, again, circle the exponent, move it 4 times to the right. So I have 30, have my decimal place, and I go 1, 2, 3, 4. Move it there, fill in zeros. And so I'd say this is going to be equal to also 300,000. So I'm going to say that B is going to be good for that one as well. Then for the next one, on part C, if I'm looking at C, again, 30 to the power 5. Again, we're not multiplying by 10, so it's almost like if we would expand it out, it'd be 30 times 30 times 30 times 30 times 30, 5 times, which is not what we need. So we're going to say no for that one. And then looking at D, if you look at the choice you have, again, it only has 4 zeros, which we need 5, so we know it's not that one. And then lastly, for the choice E, again, make sure you can divide your numbers first. So I have 1.2 divided by 4 times, and then I have 10 to the 10th power divided by 10 to the 5th power. So this is going to be 3, because 1.2 divided by 4 is 3. I'm going to say times, and then I subtract exponents, since I have the same base, and so I'm going to say this is going to be 10 times 10 to the 5th power. So we're going to say that this one is good. So those choices are going to be A, B, and E. Also, too, make sure you can see how it works on Desmos. So let me pull that up real quick. So if I wanted to try these on Desmos, again, I can type them in like this. So I'd say I have 1.5 times 10 to the exponent of 8. And I have parentheses, and I have 2 times 10 to the exponent negative 3. So again, as long as we are setting it up exactly as it looks, and we're looking for that 300,000, we have those 5 zeros, then we know we're good. Or if I want to try that last one for E, again, hit your fraction first. So now I have 1.2 times 10 to the exponent of 10. And in my denominator, I have 4 times 10 to the exponent of 5. So again, just make sure that you can see how this works. And on that last one for E, it's not 1.2, it should be 12 times 10 to the 10th power. But make sure you can use it for yourself very easily, so that way it's in there like that. All right. Now for the second one, it says select all expressions that are equal to 7 to the negative 9 power. And it says there are more than one answer. So again, you can write this around, or you can switch this around a couple different ways. But for this first one, we're going to say since we have the same base, we're going to add the exponents, which means that a is going to be equal to 7 to the power negative 4.5 plus 2, which is not what we need, so we know it's not that one. Then for the second one, for b, however, if we look at b, we can say it's almost like we're going to say b is going to be equal to, that's almost like it's 1 to the power 4.5 divided by 7, and then 2 times 4.5. So it's almost like we are raising that exponent each time. And so if we had this out, again, this would be 1 to any power is still just 1. And then we have 2 times 4.5 is going to be 7 to the 9th power. But make sure you're looking at that original value. Again, that's going to be equal to 1 over 7 to the 9th. Again, anytime you have that exponent, it's like we have a small number, or you can move it to the denominator. Either way works. So we're going to say b is going to be good for that one. Similar idea for the next one. We want to say you multiply exponents on this one. And so we're going to say that if we multiplied negative 4.5 times 2, we would say that one's going to be good. Then for part D, or choice D, we're going to say we subtract our exponents. So we're going to say D is going to be the same as 7 to the power negative 3 minus 6, which is going to be exactly what we're looking for, because we need D equals 7 to the power negative 9. So that one's good. And then for part E, a couple different parts that we need to worry about, but we're going to say like this. Let's first, let's say first add exponents for part E. So I'm going to work with these two here. So it's going to be, what's that? It's a negative 3. Yeah, so we have 7 to the power 4 minus 3, because it's, I say it's almost like we're adding a negative 3, which is going to be equal to 7 to the first power. And so we can say, again, it still has a 7 to the negative 8 power in the denominator. So again, then we can subtract. So we have a couple steps here. So we subtract our exponents. So now we have 7 to the power 1 minus a negative 8, which is almost the same as adding those exponents. So we're going to say it's almost like it's 7 to the power 9, which is not what we're looking for. So we're not going to pick that one, because we're looking for a negative 9. All right, moving to number 3, it says about 2.8 times 10 to the 7th power people live in Colorado. And that says about 2.4 times 10 to the 6th power people live in Virginia. About how many more people live in Colorado than they live in Virginia? So what we're going to have to define is this. So since it's saying, let's do green for this one. So when we're looking for the difference, we have to subtract. So what we can do is we have to make exponents the same. So what we're going to do is we're going to say, okay, if we want to change this one, we can do, it's almost like we can move that one step to the right and change our exponent to 6. So now what we're going to say is I'm going to say 28 times 10 to the power 6 minus our original number, which is 2.4 times 10 to the 6. So we have Colorado minus Virginia. So when we subtract those, again, only subtract those two front numbers. So we're going to say this is going to be the same as 25 0.6 times 10 to the 6th power, but we need to make sure that we have it in scientific notation, so I'm going to move it now back to our choice. So I can say this is the same as 2.56 times 10 to the 7th power. So just make sure you're seeing the difference between those two choices for C and D, because we need to pick the one that has the proper scientific notation. All right, moving on to number 4, it says, what number is represented by point A? Be sure to label the zoomed in line. And so make sure you remember, so I'll give you a problem just like this. What you have to do is you have to say, okay, well, this far left point is going to be the same as this, so that means this number is going to be the same as this number. Similarly, on the far right, let's do blue. We'll say this point is going to be the same as this point here. So just make sure that you're bringing that in as numbers, so that way you can help build it in. So I'm going to say, let's do right in orange. So I'm going to say this is going to be the first number, is going to be 6 times 10 to the exponent of negative 12, and then my far right number is going to be 7 times 10 to the negative 12 power. So now that I have my two left and right bounds, I can say, okay, well, what do I need to do to fill in those values in between? Well, I'm going to say this. I'm going to say that each of these numbers, so I'm going to say this. I'm going to say count by 0.1 on each tick mark. And what I'm talking about when I say these tick marks, I'm talking about, these little lines on here. So on the zoomed in line is where we're going to be at. So we're going to say, like for this first one here, we're going to say it's going to be 6.1 times 10 to the negative 12 power. And we're going to say this one's going to be 6.2 times 10 to the negative 12 power. And here is going to be 6.3 times 10 to the negative 12. Again, so on and so forth. So just make sure that you're taking, one piece at a time, and you're only increasing that tenths column because it's a zoomed in number line. So we do 6.4 times 10 to the negative 12. We have, sorry, we already did that one, so let me back up a second. Also got to be careful when you're writing these out. So this is going to be 6.5. Now I have 6.6. And I have 6.7. Again, each of these are times 10 to the negative 12 power. That way it's easier to remember. Let me actually move this over a little bit. And clear that out. Okay. And now I have 6.8 times 10 to the negative 12. And lastly, but certainly not leastly, we have 6.9 times 10 to the negative 12 power. Okay, so again, make sure you can number each of those tick marks on the zoomed in number line, which is going to be this bottom line down here. And now I need to say, okay, now that I have it labeled, it's saying what is going to be our point A. Well, we can say that our answer that we're looking for is going to be this point right here. So we're saying, okay, A equals 6.1 times 10 to the negative 12 power. All right, so now on the back, it looks like this. It says in 2022, there were about 15 million teenagers aged 13 through 17 in the United States. They each sent an average of 750 text messages per month. About how many text messages did all the teenagers in the United States send each month? So it says to express your answer in scientific notation. So that means our answer will look like this. We'll have our front value, which is, let's say, A, and I have times 10 to the power of whatever. So I'd say, let's say B. So just make sure that it's going to be in this form where A, let's say A is between 1 and 10. So we have to make sure that our value is at least 1, but less than 10. Okay, so that's what scientific notation means when we write in that form. All right, so when we say a couple other things with this, when it says 15 million, let's try writing that out. So that's going to be the same as 15 and then some commas in there, which we can change to scientific notation. So what I can do is and say this is going to be 1, 2, 3, 4, 5, 6, 7. So I'm going to say this is the same as 1.5 times 10 to the 7th power. Then I can say for 750, same idea. I can change that to a scientific notation. So let me change that to my decimal place is right here. I can say I move 2 times to the left. And so I'm going to say that what we're going to do is we're going to multiply these two together. So I have 1.5 times 10 to the 7th power times 7.5 times 10 to the 2nd power. So now what we can do is multiply these together. Again, multiply your first two values together. So I'm going to say that I have 1.5 times 7.5 is going to be 11.25. And then since I have the same base with different exponents, let me change the color. Same base of 10 to different exponents, I can add those exponents together. So I'm going to say this is going to be times 10 to the 7th power, or sorry, to the 9th power actually, because it's 7 plus 2. Make sure though, again, since we said that a has to be less than 10, we have to change this number. So what I'm going to actually do is I'm going to write our value, I have to change this a little bit. So I'm going to move it one step to the left. So I have 1.125 like that times 10, and then I'm going to increase my exponent to the 10th power. So just make sure that you're seeing it like that. So let me actually see if this will give us our same answer on Desmos. So I'm going to do the same thing that I did here, just multiply these two together. So I have 1.5 times 10 to the exponent of 7. We actually use parentheses, that way we can say multiply. And then I have my second value was 7.5 times 10 to the exponent of 2. So again, exactly as what we had. Notice how it gives us our value with that decimal point and that changed value of 10 to the 10th power. All right. Moving on to number 6 now. It says place a number in each box so that each equation is true and each equation has at least one negative number. And so if on your paper it's a little bit easier to see, but what I can do is kind of let me box some of these in because they're saying, okay, fill in these boxes, which will make sure it's a little bit easier to see. So there's box down here, box over here, and what we're doing is we're saying, okay, for these first two, we have to fill in exponents of 3, and then for part C, though, I have to figure out what am I going to place in that box for that base. But we'll get to that in a second here. So for this one, we're going to say, okay, well, my answer is going to be 0. So I need two numbers. So for this one, it's just going to be, let's say, let's do blue. I need two numbers that add together. Try that again. There we go. Add together to get 0. So it's any two numbers that add together to give you 0. So for example, I could say, let's say 5 and -5 would be an option for that one. Or it could be 6 and -6, or 10 and -10. Any of those options would work as long as it's two numbers that add together to give you 0, because that's our exponent in the answer. Now for B, I can say similar situation. So let's actually do, split it, try that again. Something like that. Now I have to say I need a number. So I need a number that subtracts because, so same base. We're going to say division. Division means subtract exponents. So I can say, okay, well, if our original exponent is 3, what I could say is this. I could say, well, if I change this to maybe a -1. It's almost like we're subtracting those two. So I would say 3 minus a -1 is going to be equal to 4. So I'd say in this one I'm going to have a 4. Where in the first one I had a -1. Then for the last part, I'll do in red. The last part, I have 3 times, 3 to the -3rd power times a number to the -3rd power equals 6 to another box. So I actually forgot to draw this box in. That's okay, we got this here. A little higher here. There we go. So we're trying to figure out, okay, what number goes in these places? Well, we have to say this. We would say in red, so same exponent means to multiply bases. So basically what I'm figuring out is what number times 3 equals 6? Well, I can say for that one, I know it's going to be 2. And so that means that my exponent is going to be -3. So it keeps the same exponent. I just have to make sure that I have the correct base for this one. All right. And then lastly, for number 7, for number 7 says, here are the approximate populations of 3 countries expressed in scientific notation. It says Panama is 4 times 10 to the 6th power, Peru is 3.2 times 10 to the 7th power, and Thailand is 7 times 10 to the 7th power. It says Lin says that more than 20 times as many people live in Thailand than in Panama. Is this correct? And explain how you know. So let's figure it out, some different parts for this. So we're going to say for Thailand, again, Thailand is here, so we have that. And Panama is here. And so what we can do is I'm actually going to change this value when I say this is going to be equal to 70 times 10 to the 6th power, because what I need to do is I need to divide. So I'm going to divide these two values. So I take and say, let's do different color now. So let's say I have 70 times 10 to the exponent of 6 divided by my other value, which was 4 times 10 to the exponent of 6. When I divide these out, again, the 10 to the 6th power cancels out. So I'd say this is 17.5. So we're going to say that no, it is 17.5 times larger. All right. Then for part B, it says decide what power of 10 to put on the label for the rightmost tick mark on this number line so that all 3 countries' populations can be distinguished. That means we want to make sure that we can plot them, which is that part D. So I need to figure out, okay, what am I going to put in this part down here? So I would say this would be our largest value, or 2 of our values are to the 7th power, so that just means I have to put to the 8th power. So I'm going to say that this is going to be 10 to the 8th power. And then for part C, it says to label each tick mark as power of 10. And so I can count, well, I should have 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's very similar to what we did in that early one, but we're actually looking at this number line here. So we're not looking at the zoomed in one, we're actually looking at the top one. So what they're counting by is they're counting by 1, 2, 3, so on and so forth, times 10 to that power. So what we're going to do is we're going to do exactly that. I'm going to say, I'm do in black now. I have 1 times 10 to the 7th power. I have 2 times 10, put down, 2 times 10 to the 7th power. I have 3 times 10 to the 7th power. I have 4 times 10 to the 7th power. 5 times 10 to the 7th power. 6 times 10. Again, only increasing that front number because we don't have a zoomed in line, so we're not going to be increasing the decimal places. We're just increasing that front number attached to the 10 times, or the 10 to the 7th power. So then we have 9 times 10 to the 7th power, and then the rightmost tick mark is going to be 10 times 10 to the 7th power, which is the same as, this is going to be 10 times 10 to the 7th power, which is the same as 10 to the 8th power because you add those exponents. So we did part C, and then it says to plot and label the 3 countries' populations on the number line. So I have a couple colors already. So I have purple is Panama, and that's going to actually be below, this first value because, again, this is 10 to the 7th power, and we only have 10 to the 6th power, so we're going to say just going to be just below halfway. So we're going to say if that's halfway, let's do like right here and label that Panama. Then for Peru, let's do orange for Peru. And so that's at 3.2 times 10 to the 7th power. So we're going to be just to the right of 3 times 10 to the 7th power, and we can label that as Peru. And for Thailand, let's do pink, and let's say 7 times 10 to the 7th power, which is a tick mark right here. So we can say that's going to be Thailand. So just make sure that you can see those different parts with those different labels. Make sure you're practicing switching between scientific notation and standard form. Make sure you know those rules for your exponents. And as always, super slam that subscribe button.